So our next part is control hazard. First consider this example. These 12, 16, 20, 24 and 36, these are address of these instructions. Okay, and here these instructions are given. First, branch if equal, these instructions are given, then AND operation, OR operation, then also add operation and XOR operation. Okay, so this branch if equal means if R1 and R3 after performing these two 1, if these two 1 are equal, this direct jumps to this address of 36 for the XOR operation. Okay. So branching instruction is also a jump instruction, and this control hazard occurs due to this jump instruction or due to this branching instruction. So suppose it has 5 phases. Okay, fetch, decode, execution, memory access and output. Okay, so first of all this instruction perform these 5 phases and so on. When this first instruction goes to decode phase, then in second instruction the data will be fetched, and when it also decode phase, and this first instruction when goes to executing phase, it all goes decode phase, and third one into fetching mode. Okay, data fetching mode, and if when this is decode phase and then 24 is in fetching mode and so on. Okay, so here you can see when this is in the fourth clock period, here 12, when this first instruction of address 12 using memory, and this 24, this fourth instruction also using memory, because this is also in fetching mode, and we know memory contains the data. So when it using memory for output, and in this fourth process fetching the data for process, it also access this memory. So here conflict occurs. That means 3 sequential instruction start or begin execution in pipeline before knowing where to jump, because in the first instruction if it is equal, then it given R1 and R3, if it is equal, then it goes to this instruction 36 number 36. Okay, but here the as pipeline is a sequential manner, so it execute in sequential order. Okay, 12, 16, 20 and 24. That means these three instruction, these three sequential instruction start execute in pipeline before knowing where to jump. So here if it is equal, that means there is no need to perform these three, this one, these three instructions. Okay, so here branch penalty occurs, that means time loss occurs. That means it in pipeline these three instruction stall due to this control hazard. So here control hazard occurs, here conflicting. So here control hazard occurs because without knowing where to jump, these three instructions can perform in sequence. So this is control hazard. The instruction fetch unit of the CPU is responsible for providing a stream of instructions to the execution unit. Okay, the instruction fetched by the fetch unit and in consecutive memory location, and they are executed. But problem arises when one of the instruction is branching instruction. This one is branching instruction. Branching instruction means if it is equal, then it goes to the, then it jumps to the jumps to the another instruction. Okay, so in this case all the instruction fetch in the pipeline for consecutive memory location are invalid now. This means when these are equal when it goes to this instruction, and 16, 20 and 24 these instructions are performing. That means there is no need to perform these three. Okay, so these are invalid and also removed from this, from the, and also removed. Okay, so this one is called flushing of the pipeline. Okay, and this problem occurs when branch instruction execute over sequential execution. That means these are sequential execution. Okay, and pipelining all instructions are performing in sequential order, but when branch or jump instruction occurs, these instructions, that means you have to jump this. If it is equal, you have to jump 36. That means you have to jump another instruction. So here control hazard occurs.